Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is inverse trigonometric functions. This is an introductory video on this topic. In previous classes you have studied about sine function, cosine function, tangent function, cotangent, secant and cosecant functions. Please note that whenever we say sin x, cos x or tan x, the x corresponds to an angle and this angle is given in radians. So we can see here it is n pi, 2n pi plus pi by 3 as the solution for x. The angle here pi by 3, they are in radians. This is equal to 60 degrees. Similarly, for tan x equal to minus 1 by root 3, x equal to n pi plus 5 by 6. Why we are writing n pi? Sin x is a, or cos x or tangent x, they are a periodic functions. Means when x equal to, when say n equal to 0, so x will be 0. When x is 0, sin x is 0. When n equal to 1 or x equal to pi, sin x is 0. So at different values of x, sin x will be 0. So that is why it is called a periodic function, repeating itself. Periodic means repeating. Now you may be wondering, okay, I know that the solution, so why I need inverse trigonometric function? Why it is required also? Now you know that these solutions can be easily deduced from the table values. You know cos x equal to half. So x is equal to 60 degree. You know that, and this can be converted into pi by 3. We have written pi by 3. And 2 and pi plus minus pi by 3 is a general solution. Because there are many values of x at which cos x equal to half. Now suppose I take another value which is not given in the tables. For example, I take sin x equal to 1 by 3. Now I don't know what is the value of x which will give me sin x as 1 by 3. So how do I represent mathematically such equations? That is the purpose of inverse trigonometric function. So we write sin x equal to 1 by 3 as sine inverse 1 by 3. So x will be sine inverse 1 by 3. Similarly, if cosec x is equal to 5 by root 3, x will be cosec inverse 5 by root 3. So this way of writing inverse trigonometric functions you should be familiar with. Now let us also recap from class 11 at different quadrants what are the positive values of sine, cosine and tangent. I have written here, this is first quadrant, this is second quadrant, this is third quadrant and this is fourth quadrant. I have written here A, S, T, C. You should remember this. In the first quadrant, A means all are positive. So if angle is between 0 and 90 degree, all sine, cosine, tan, cosecant, secant and cot are positive. Similarly, in second quadrant, when x is between 90 and 180 degree, only sine is positive. Cos and tan are negative. If cos and tan are negative, secant and cot also will be negative. If sine is positive, cosec also will be positive. Similarly, in third quadrant between 180 degree and 270 degree, only tan is positive. It is shown by this green color. All other trigonometric functions are negative here. Similarly, in the fourth quadrant, cos is positive. So we have written cos and secant positives. Also all others are negative. So you can remember as ASTC, all silver tea cups, or all students take coffee. Now there are some very basic things which you should understand. For example, sine inverse x. This is called as the inverse trigonometric function. Sine inverse x is not equal to sine x minus power minus 1. What is sine x power minus 1 is 1 over sine x. This is like a standard mathematical function. For example, 4 power minus 5 we can write it as 1 over 4 power 5. Similarly, sin x power minus 1 is 1 over sin x power 1. So These two are separate things. You should understand. Sine inverse x is not same as sine x power minus 1. This is sine x power minus 1. This is called sine inverse x. Similarly, it holds good for other trigonometric functions. Now let us plot first graph of sine x. So we have written as y equal to sine x. On the y, we will get the values of sine x, and x will be taking from 0 to or from minus infinity to infinity. Let us put first 0. When x is 0, y is 0. Y sine 0 is 0. When x equal to pi by 2 or 90 degrees, sine x is 1. So we are getting 1 here. So we are getting values at different values of angle. So these are the angles. 0, pi by 2, pi, 3 pi by 2. We see that the function is repeating itself. That is why we call it as a periodic function. Now it is important that the domain is from minus infinity to infinity and range is minus 1 to 1. Now we want to plot y equal to sine inverse x. Previously we have plotted y equal to sine x. We simply change x and y. X and y change means now the graph will be symmetric along the y-axis like this. Previously it was along the x-axis. Just we have shifted x and y, and x will be ranging from minus 1 to 1. Again we observed that when x equal to 1, y can be pi by 2, y can be 3 pi by 2, y can be 5 pi by 2. So there are different values of y for each x. So how does it matter? It does matter. Now we are going to introduce you very special term called as principal value branch. So here we have drawn that y equal to sine inverse x curve. So we have drawn here. Now the concept of principal value branch is used in the context of inverse trigonometric functions. Inverse trigonometric functions are not one-to-one. Why they are not one-to-one? Which means that for a single value of x, there can be multiple of values of y. We have seen when x equal to 1, y can be pi by 2, y can be 3 pi by 2, or y can be 5 pi by 2, and so on. So we are getting different for each value of x, different values of y. This property contradicts the definition of function which states that for each value of x, there should be a unique value of y. Then only it is a one-to-one function. So to make inverse trigonometric functions one-to-one, we restrict their domains. This restricted domain is the principal value branch. So I have drawn this with the red color here. So for sine inverse x, the principal value branch is pi by 2 to minus pi by 2, or minus pi by 2 to pi by 2. So we'll be, whenever a question is given on principal value branch, you should select your angle between these two values only. You need not bother about others. Now this I had given principal value branch of inverse trigonometric functions. Other functions, sine inverse x we already saw, minus pi by 2 to pi by 2. Similarly cos inverse x, principal value branches 0 to pi. These are principal value branches. Tan inverse x again minus pi by 2 pi by 2, and so on. For cot inverse x it is 0 to pi. Now let us take one example. We need to find the principal value of sine inverse 1 by root 2. We let this expression as y equal to sine inverse 1 by root 2. Now we know that if we can take this sine on the left side, it will become sine y equal to 1 by root 2. Or to understand this, if sine y equal to 1 by root 2 is given, y will be sine inverse 1 by root 2. So we have let this as y and taken sine here, sine y equal to 1 by root 2. But what is 1 by root 2? We know that sine 45 degrees or sine pi by 4 is 1 by root 2. So RHS we write it as sine y equal to sine pi by 4. When sine y is sine pi by 4, y will be pi by 4. Since we need to find the principal values which is between minus pi by 2 and pi by 2, yes, pi by 4 is in between these two, hence principal value is pi by 4. This is the answer. Now some important properties of inverse trigonometric functions we should understand. Sine of sine inverse x is x. This is important. Again I repeat, sine of sine inverse x is equal to x. Similarly, cos of cos inverse x is x. Another important property is sine inverse of sine y is again y. Cos inverse of cos y is y. So we will be using these properties frequently for our problems. Let us take another example. We want to write cot inverse 1 by square root of x square minus 1 in the simplest form. Now to get rid of this, we know one property. If cot inverse cot x, let us assume this is cot x for a moment, then cot inverse cot x will be x. But how do we get x here or some angle here in terms of cotangent? How to get cot theta here? So that cot inverse cot theta will be theta and it will be in simplest form. So we want to get this as cot theta, cot of some angle. How do we get it? If we can make denominator as tan theta, then this 1 over tan theta will become cot theta. So how do we make root x square minus 1 as tan theta? Now we recollect our earlier basic rule that 1 plus tan square theta is sec square theta. So if we put x equal to sec theta, we substitute x equal to sec theta, this will be sec square theta minus 1, square root of that will become, this is tan square theta, square root of tan square theta is tan theta. So we substitute here x equal to sec theta. So this expression will become 1 over tan theta or cot theta. So this will be cot inverse cot theta, which is theta. Cot inverse cot theta previously we have seen according to property is theta. But what is theta? Theta is sec inverse x. So that's what we have written. So this expression full simplifies to sec inverse x. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.